the first lecture, which is the Introduction to Chemical Engineering Computing, and we are going to start with Microsoft Excel. We are going to spend the first few weeks, probably 2 to 3 weeks, on Microsoft Excel. After that, we'll move on to MATLAB, and then the last half of the semester, we are going to spend on Aspen HYSYS. Okay, so today I'm going to give you an overview of Microsoft Excel. I assume that you already know the basics of Microsoft Excel. If you don't know, please let me know. I can share with you some videos, or you can search it on your own on YouTube or any other website, and you'll find tons of tutorial on there. So for Microsoft Excel, mainly we'll be using Microsoft Excel to solve problems related to chemical engineering like material and energy balance, thermodynamics applications, which mainly are nonlinear equations and system of nonlinear equations. We will solve them, and we will also try to cover some other advanced topics in Microsoft Excel. So from introduction point of view, if you open Microsoft Excel, I'm sure you're familiar with the basic graphic user interface, which is the main control panel. From here you can you have main tab, which is the home button, and then you have the insert button. Let me show it to you in Microsoft Excel. So for example, if you have the Excel tab here, you have the home button. From the home button or the home tab, you can see there are different formatting options, mainly the fonts and these things. The insert option is used to insert tables or pictures or graphs or whatsoever. And similarly, you have many other tabs, and you can go through them. So from the home or in the main menu, you can see there could be different Excel sheets. Like for example, sheet number 1, I can add more sheets here, sheet number 3, and so and so. So each sheet can be your one working file where you can put some data and do some data analysis. Now inside each sheet, you may notice that there are columns which are named by letters A, B, C, D, and so on. Similarly, you have rows which are numbered 1, 2, 3, and 4, and so on. And each cell has a reference, and this cell is A1. You can see the name here, A1. A1 refers to this cell because it is the first row and the first column. This cell is A2, A3, and similarly this is B1, B2, and so on. Now if I put any value in, let's say cell B2, let's say I put a value called 2, for example. Now the cell B2 is has a value, it stores a value of 2. Let me put another value, let's say for example here 3, 4, 5, 6, and so on. I can keep pressing enter and put values. Let me name this cell or this column as my x values. We call it x. I can center the number. So with these numbers, I can select them and put the center it from here. Similarly, let me say these are the y values, and for the y, I assume that there is a formula. Let's say it is sine of x plus 2x, something like this. Now to put a formula in Excel, I need to start by using the equal sign. So if I put the equal sign, I would say sine of x. Now if I write the word sine, basically in Excel there are built-in functions, and most of the mathematical functions are already available in Excel. For example, sine, the trigonometric sine, cosine, all of them. The exponential is available. All the additive functions like average or sum, and so on. Anything there are any mathematical function that you can think of is most likely available in Excel. So right now we are assuming that y is equal to sine of x plus 2. So I can say sine, I can write sine, double click on it, it will convert it to capitals. Now I can select the value of x. Now look at the formula. You can see that it shows the reference point. So it is taking the value from cell B2. And I need to close the parentheses, close the brackets, and so it calculated from let's say we said that sine of x plus 2x, so I'll write here plus 2 times x. Okay, now if I want to apply this formula to the next cell, I can just bring the cursor here. You may notice that it's converted to a plus sign, and now if I drag it, it will drag the formula, it will apply the formula to the next cell, and so on. Now let me go back and see. Look here, it is applying it to B2. When I click on the formula, it is showing me the cell that is being used in the formula. Now if I take the other one, you see it's automatically being dragged and automatically being updated. So it is applied to B3, and so and so. The last one, you see it is applied to B6. Now There's another thing which I want you to recall is if you want to make a cell or a row constant. For example, let's say we have function z and it is equal to sine of x. Let's say the same formula, sine of x plus 2 times x, okay? And let's say we want to divide this by this whole function by a constant, and let's say the constant is we don't have put it here, but let me put it here. Let's say assume the constant value is in this cell. Okay, right now there is no value, but let me put a value here. This is let's say my constant k, and k is given as, let's say, point, or let's say 1.5. Okay, now I want all of this function to be applied, but remember h2 now is a constant, or a k. It is called k. K is a constant now and it is not changing. Now if I drag this formula to the other cell, remember what happens? Because all of the cells here are relative. Okay, none of them is a constant. So this cell is a constant, this cell is a constant, sorry, this cell is a relative, these are all relative. So when it comes to this cell, it converts from h2 to h3, this cell, and this cell has no values. So to be correct, what I need to do is I to make the cell constant, and you can make it constant by putting a dollar sign, so, or using F3 button. Yeah, F4 button, sorry. So if you press F4, it will put a dollar sign before the column and a dollar sign before the row. So it means both the row and the columns are constant. So when I press enter and now I drag the formula, it will change the other cells but not the cell h2. H2 will be constant in all the formulas. So if we have any constant, we can use it this way to make the cell. And similarly, if I want to vary the k value in x direction, I can make it as a, for example, as the row is constant while the column is changing. So I'll put a dollar sign before the row. In that case, if I drag the formula in the horizontal direction, I mean by varying the column, so the formula, the cell value will change in x direction, but it will not change in the, uh, I would say, in the rows. The row will be constant. Similarly, I can apply many other functions, like I would say, let me take the average of these three functions. So these three values, I'll write average formula. I'll select these two cells and I close it. It will give me the average, and I can apply it to all other cells. I can also, for example, do the average by writing the sum, and from the sum I select the range, and then we have, since the n is 2, we can divide by 2. This same thing, you can use either the average or the sum formula. Similarly, you can apply any other mathematical computation they would like to. Now imagine if I want to plot this, I can plot x against y very easily. I'll select the columns x and y, go to insert, and plot a graph. I want to plot a scatter, I want to plot a line, or I want to plot without plot markers, so I can choose one. Now if I plot the line, by default it's selected x and y, but if I would like to change, I can right click on the data series and click on select data, and I can change anything. For example, series 1, I can click on edit. I can change the name. I would say y data, for example. Let me give it a name. I can select the x range. I can modify it if I want to. Similarly, the y range, I can select it, I can change it, I can modify it. Okay, and click OK. I want to add another series to it. I'll click on add, and let me write it, give it a name. The name for this series is z data, and the x values are the same, while the y values, I'll delete the previous one and I'll select the range. Remember, to select the range, you need to click on the mouse and then hold and drag it. Okay, so this is another series. I want to add another one. I click add, and let's say I call it average, and again the x, this is my x series, and the y, this is the uh, third one, and click OK. Now I have three series of data, but remember, this plot is incomplete. Why is incomplete? Because the information here is incomplete. We don't know what is on the x-axis, we don't know what is on the y-axis, we don't know what these series represent. Okay, so to do that, we can come here from the top to the design tab, and we can click on the chart element, and it can be from here we can add the horizontal x-axis, for example, sorry, the titles. So the title for the x-axis, we can add the title for the y-axis, and similarly we can add the legend, and we can add it for the top or the left or the right side. So I prefer it to the right side. I'll add the legend here. So now we know that the blue line represents the y data, the orange line represents the data, and the gray line is the average. I can change the x-axis title. I will say this is my x data, and this is my y data, or let's say a function of x, for example, whatever value it is. Okay, similarly I can change the fonts and these things if I would like to. I can change the grid lines. All of these functions are available, and for the fonts I can simply, if I want to change the color, I can make it black. I can change it to black here, and so on. So now once you work on on a plot, and you want to use a similar plot again, there is an easier way to save this plot as a template and apply it to the next plot. So I can do it, right click on the plot. Okay, okay, if you want to change the plot markers, this thing, you can double click on it. Okay, and you will see the plot marker options here on the right. From here you can say the marker options, and from the automatic you can go to built-in and change it to triangle or whatever symbol you prefer. Okay, you can change the size, you can change the fill options. Okay, and so and so. So once you do that, you see it change it to triangles. I want to change this one to maybe something else. So from here, markers, built-in, and instead of circles I want it to be stars, for example, and that's it. So now once everything is ready, I can right click on it and select the save as template, and I can save it as my sample one, for example, any chart you would like. And next time when you plot your chart, for example, I want another chart which is quite similar to this one, the range and these things are similar. I can right click on this and I can say change the chart type, and from here go to my templates and click OK, and all the template setting from my previous template will be applied to here. You see we have the legend, now we have the titles, and so and so. So remember, whenever you are presenting your results in form of a report or presentation, you should always present a graph that are nicely presented and they have the complete information, what is on the y-axis, what is on the x-axis, and what are the units. If there are different units, this is better. It is always better to show the units in either by using a slash sign, or by using, preferably by using brackets. For example, you can write the units here. Okay, and always it is important to show the legends of the graph. Okay, and here are some examples. For you can see it here, the volume of the sphere is shown and the radius. Another thing is you can always play with the axis. For example, if you want the x-axis scale, you can change it from 0. Let's say I want, instead of 0 I want it to be from 0.5 to 6.5. Okay, or let's say I want it to be from 1 to 6.5. I can always play with the grid lines. Instead of 2 I want it to be, let's say, 1, and the minor units I want it to be 0.5, for example. Okay, I can always change the tick marks, and these options you should explore it yourself. I can change the scale. If I want it to be on a log scale, I can change it to a log scale. Okay, or the same can be applied to the y-axis. Okay, so I want you, what I want from you is to go back and review these options for Microsoft Excel, all the basics. How can you to put a formula in Excel? How can you use the basic function in Excel? And how can you plot the data? All of these things I need you to go back and revise, because you will be using these things frequently during this course. Next important thing I want you to I want you to know is naming the cell. Now, as I told you, for example, here this cell I want it is a value of k, right? It's showing me the value of k. Now it is 1.5, but in Excel doesn't know that it's k. Excel calls it as h2. In Excel it is always referenced by cell h2 because it is in the h column and second row. Let's say we have another value, for example, for the CP, for example, 14.18. That's CP for the water. Okay, let's say we have another value for pressure, and let's say it is zero point 0.5. We can write, better to write the units here sometimes to show clearly the things clearly. Now we have, for example, temperature, and the temperature is, let's say, 3 to 5 Kelvin, and some other parameters for, let's say we call it Z, and let's say we call it N, and the Z is 0.2. 9 and n is 10, for example. I'm just putting random values. Now if I want to use these values in a formula, let's say my formula is cp times k divided by p times t plus z by n, something like this. Some strange formula is just coming into my mind and I'm saying it. Now, it is always easier to put the formula in terms of these constants or these names instead of using the cell reference, because when you are using the cell reference, it is difficult to trace the error. So what I can do is I can call this cell as K by changing the name. So how can I change the name of the cell? And by clicking on the cell, and I can come here and from H2 I can change it to K. Okay. So now this cell will be named as K. Similarly, this I can call it CP. The easier way to do it, we can select both of them, both the list, any the names and their values, and then from the formula tab here, from the formula, I can go to the create from selection, and I can choose here the left column as the name. So when I click on OK here, you can see that the first this one is K, the next one is CP. So what Excel did here is choose these values or the whatever we have written here in this column, assign it as a name to the this cell. Now whenever I want to write a formula, let's say my answer, I would say equal to let's say K times, you see when I used K, it is automatically referencing to the H2 cell. K times CP, for example. You see when I write CP, it's already available here and it is being highlighted here, CP, and I would say divide by mm, P times capital P times T. Okay, and since it is not clear here, I will write the rest of the formula here. So P times T, and I would like to put brackets always to be on the safe side when you're not sure about the numerator and denominator, whether Excel will consider it or not. So better to put brackets. Plus I would say Z times N, Z times N, and you see all my formula is easier and I get my answer. Now imagine if I did a mistake here in this formula, it's easy for me to analyze it and trace and find the mistake. So that's just for your convenience, and I always recommend to name the cells, okay, and use them in the formulas later on. Clear? Now the next part is the we are done with the basic operations, rows, columns, and naming the cells. Basic operation like mathematical functions. You can also you can explore yourself the making. How can we make the tables in Excel and format the tables and provide headings, etc. The plotting data, there are many functions available in Excel. We just explore one, the scatter plot, but you can always explore other options. If you go to insert in the plot options, there are many. For example, we have the bar chart, we have the pie chart, and many more. Okay, you can explore them yourself. And now we will focus today on complex mathematical function and data manipulation, mainly solving the nonlinear equations. So in chemical engineering, you face different types of equations as you progress during the courses. For example, right now you have done material and energy balance. So there, when you conduct material and energy balance, you will get a system of algebraic equations or sometimes polynomials, but mostly a system of algebraic linear or nonlinear equations, which can be solved analytically or numerically. So we get algebraic equations and polynomial equations sometimes, which can be solved by using matrix approach or other nonlinear technique. We get sometimes the implicit equations in which the relationship between x and y is not clear and the analytical solution is difficult, like the equation for the friction factor, the Fanning equation, and sorry, the Colesberg equation. So the friction factor here can be calculated by using a numerical technique, and we'll see it in this course. Similarly, you may face ordinary differential equations when you conduct the non-steady state material and energy balance, the heat equations, for example, or the concentration profile in the reaction kinetics. They are all ordinary differential equations, like the rate of change of concentration with respect to time is given by the rate constant times the Ca. And similarly, the rate of change of temperature or the temperature profile in a cylinder is given by this equation. Similarly, we'll see how we can solve these equations, the ODEs, by using MATLAB. The PDEs we will not touch them in this course, but the PDE basically when the x or your desired variable, which is the dependent variable, is changing with respect to more than one variable, and there are more than one uh, independent variable. For example, here you can see the concentration is changing with respect to time, as well as it's changing in x direction. So this is a partial differential equation. Integral equations are more or less the same as ODE, but they are designed in a way so that we can integrate them easily. So here, if we take the equation, for example, the volume is basically equal to, for a plug flow reactor. You will study this equation later on in the 402 reaction kinetics course. So it is basically the flow rate times the Ca naught, the equation, the integral equation from 0 to xa divided by dxa by minus Ra, while minus Ra is basically dc by dt, and it could be kca to the power n or kca square. So we have an integral equation, and we'll see how we can integrate such equations by using numerical techniques. So these are the different types of equation. Regression also, we will see regression is basically used when you have a set of experimental data and you have a mathematical model, and we are interested to find out certain unknown parameters by fitting the experimental data to the mathematical model. So the solving strategies, if we classify them briefly or in a bigger classes, they are analytical and numerical. So analytical means the exact solution. Like if I would say 2x minus 4 equal to 0, in that case x will be equal to 2. That is an exact solution. But numerical solution is when you are using the approximation methods, okay, or numerical techniques, like for example Newton-Raphson method or any other tangent method, bisection method. We use these numerical techniques or other built-in techniques that are available with the software to solve for the value or approximate value of x, y, or any other variables that we have. So there are many tools. In this course, mainly we'll be focusing on Excel, MATLAB, and we'll focus on Aspen Suite, particularly Aspen HYSYS. Excel, MATLAB, Mathematica, Polymath, these software, they are general purpose, and you can use them for not only for chemical engineering problems but other mathematical problems also. On the other hand, Aspen HYSYS or Aspen Plus is a software package specifically designed for chemical engineers. Okay, and here we have all the properties packages already available. Like for example, if I want to have to obtain certain heat requirement for heating the water from one temperature to another one, I don't need to go to any other data bank and find the CP and the temperature dependence and all these things. In HYSYS, all these packages or all these properties are already available, or it can be calculated by using a desirable equation of state. Okay, so it is specifically designed for chemical engineering, and we can design using Aspen HYSYS. We can design a unit operation or a whole process, and all the equipments and all conduct all the energy and material balance very easily. Okay. Uh, so in the Excel part, we'll focus mainly on solving the linear algebraic equation or system of equation, and we'll focus on the example from material balance, non-reactive system, and some reactive systems also. And the approach that we'll utilize is we'll conduct material balance on a process or a system and come up with a system of equations and solve them by using matrices. We'll also solve the nonlinear equations and system of nonlinear equations. Okay, heat and mass transfer system, reactor design. So you don't need to have a knowledge of all the theory. I'll give you the required knowledge or the required things that are needed, but mainly we are interested in solving the equations only. All right. So the we'll start with this part today. Okay, and we'll use Excel solver to solve some example related to nonlinear equations and system of nonlinear equations. So solver is a functionality available in Excel, okay, and you need to make it available. By default, it's not shown. So to make it available in Excel, we need to click on File, okay, and Options. From the options, you will be able to see add-ins from the left side, and from add-ins, then in Excel add-ins, click Go, and you will see solver here. You need to click on it and click OK. For me, it is already available, but you need to click solver add-in and click OK. Once done correctly, you will be able to see inside the data tab, you will be able to see solver on the very right side here. This is the solver. Okay. So what is the purpose of the solver? Let me show you. So basically, a solver is used to obtain a desirable value for a function or for any cell by changing another variable cell. For example, if we have an equation, a quadratic equation, let's say in this case, which is uh, 6x squared plus 11x minus 35 equals 0. Look at this equation. I want to solve it for x. I know you can solve it analytically very easy, but let us use the solver approach. Okay, we will then move on to complex equations later on. Now in this equation, if I want to solve it for x, remember it is a quadratic equation, so we have two roots. If I plot f of x against the x values, I can see clearly that there are two roots. Okay, two roots means the value of x basically, which satisfies the right hand side and is equal to the right hand side, left hand side and right hand side. That will be the true value of x. Okay, and if I get a value of x and I put it in this equation and I get 0, it means that is a true root for x. So we can see here from the plot, you can see that this point is crossing the x-axis, this point is crossing the 0 line, this is one root, and this line is crossing the 0 line, this point, so it is another root. Now let me show it to you in Excel. For example, if I put this here, we will use solver to solve it, but let's see. So let us say I call this cell as x, I put initial value, let's say 1, and then I say my f of x, I say equal to, and x squared plus 11x minus 35. 6 times x. For 7th time, I will not name the cell. It's 11 times x is 35. 6x squared plus 11x minus 35. 6x squared. Okay, good. Now, if to find the root, I can try different values of x. For example, now f of x is minus 18. I want it to be 0. Let me try 0.5, for example. It is minus 28. Let me try 1.1. It is minus 15. Let me try 1.2. It is minus 13. And it's coming close to 0. Let me try, for example, 1.5. It is minus 5. Let me try 1.6. It is minus 2. We are coming close to 0. But it is a troublesome exercise if I do it manually. Why not use the Excel tool? There are two tools to use. We can use solver or we can use the what if analysis or called goal seek. Let us do it by solver first and then we can go to goal seek. So for solver, if I open solver here, there is a menu, a pop-up, a new pop-up window. Here we have a few things. One is the objective. Okay, this is what I want to achieve. For example, I will select an objective cell and I can choose it. I can ask Excel to make it maximum or minimum or a certain value. Similarly, I can choose a variable cell, and in the variable cell I can choose the value of x to change it. So for example, in this case my objective cell will be the f of x. Let me select here, delete this, and I'll choose f of x as my objective cell. Okay, and I want to make it 0. Why? Because when f of x is 0, that will be my true value of x or the solution that I'm looking for. So I choose the f of x cell, which is D3 in this case, as my objective cell, and I want to make it to value of 0 by changing which cell. I want to keep changing x until I obtain the solution. Now here we'll see it in the next slide. We can also apply some constraint. For example, I want x to be positive or I want x to be negative and so and so. Or if you have multiple equations, we can use constraint. But right now we'll just keep it simple. So this is the objective cell, which is f of x. I want it to be 0 and here is the value of x which I want to keep changing. Remember, we can have multiple variable cells. Okay, I can for example, I can have x, y and z three values. I can keep varying them. So the options will right now we'll leave the options as default and we click on solve button. When I click on solve, it is solved and I click OK. Now look here, the f of x is nearly 0. It is 1 into 10 to the power minus 7. Okay, so it's a very small value and we can say it's 0, and the solution is 1.667, and you can see it here. The one of the solution is it is 0 and this is 5 1 2 3, so it is nearly 1.6 here. We can see it. Now, how to choose the value of x? This is an important question. Okay, the initial starting value. So the starting value should be an educated guess because the solution really depends. Now, imagine if I put minus 2 here, initial value, and go to solver and solve it. You see, it give me 1.66 again. But if I put a value which is the other solution, which is I think minus 3 or minus 4 something. Let's say I put minus 6, and now I solve it again. I'm still getting one because maybe there is a constraint. Otherwise it should give me the second solution also, which is I think -1, -2, -3, -4. It should give me the second solution also. Let me try it. -4. Solve. Okay, I know why it's not giving me the second solution is because if you go to the option, it says make unconstrained variable as non-negative. If I check this, okay, now if I make it -5 and solve, to give me the other root, which is -3.5. So basically in the options, this was restricting it to make the solution as positive only. So when I uncheck this option, now it can give me the negative root. And if I check the option, if I give the initial guess as 2 and solve it again, it should give me the positive root. So the solution, or the solution of x in this case specifically, depends on the initial guess. If I give an initial guess near to this point, it will give me this solution. If I give it near to this point, it will give me this solution. So usually in the complex problems, you obtain the initial guess by simplifying the problem first and solving it. Or for example, if you have an equation of state, you assume it ideal and solve it and use that value as initial guess in the complex equation of state. Or in certain cases, there could be an educated initial guess provided to you by from the literature or by the instructor sometimes. Okay, so but remember, the solver really depends on the initial guess that is provided. Now if you look to other equation, now it's a periodic equation. Here we have multiple roots, and of course when you want to find a solution, you need to provide an initial guess close to the point of interest. Okay, it could be a guess value from here or here or here. To solve this again, we just need to put a value of x and then f of x, and we would like to make it f of x 0 in the objective cell by varying the value of x. We can also solve the multiple equations. Okay, multiple equations by using the solver. For example, if you have three equations here, x cubed minus 2y equal to -2 equal to 2, and so and so, these three equations. Now here we have three equations and three unknowns. Okay, and I have one equation, x cubed minus 2y minus 2, if I take it to the side, equal to 0, x cubed minus 5z plus 7 equal to 0, and y times z square minus 1 equal to 0. So three equations and three unknown. I can solve it by Excel solver. How? We will have one objective cell, three variables, because x, y, and z all the variables, and we have one objective cell, and the other two we can put them in constraint. Let me show it to you. So from here, yes. So here you can see, for example, we can select the value of x. Let me put 1, 1, and 1 initially, so we don't know the solution right now. Okay, I put x, y, and z, these are the cell. I put three equations, which is the first one is x cube, and this here you can see it, d2 cube minus 2 times d3 minus 2. So x cube minus 2y minus 2 equal to 0. The second equation is x cube. This is d2 cube minus 5 times z plus 7. This should be plus 7. Yeah, it is plus 7 here. So here it is a typo. Correct it. And similarly, the third cell, or the third equation, y times z square minus 1 equal to 0, which is y times the z square minus 1 equal to 0. Now I have three equations, okay, and what I want to do is I want to solve them for x, y, and z. And remember, if I get the true value for x, y, and z, I should get this equation equal to 0, this one equal to 0, and this one equal to 0. All the equation must be satisfied for a true solution. So how to do that? We'll go to solver, data, and solver. So the first one is to choose objective cell. One of the three equations, any of these three, okay, I can choose them as my objective cell. I can choose the first one as objective cell, okay, and the variables are three here. We have three variables, x, y, and z, okay, not a single variable. We have multiple variables. The other cells, let me delete them, they are already available. So the other two equations, now I out of the three, I put one in the objective. The other two, I can put them in constraints. I can click on add and select one of the cell and click equal to 0 and click add button. Now this the third one equal to 0 and click OK. Now I have two two of the equations in the constant. So if you have five equations, for example, and five unknowns, you can put one in the objective cell here to make it zero, and the other three or other four, whatever number you have, you can put them in the constants and click on solve. When I click on solve, I think something is missed. Okay, I was previously in this sheet, so now, yeah, it is solved already. Solver, solve. Okay, it's showing up this sheet. I don't know why. Let me close this. And here, so you see now the equations are solved already. You see 1.36, 0.27, 1.9. This is one solution, and you can see all the numbers or all the equation 1, 2, and 3, they are nearly zero. Since this is not the exact solution, so we will not get exactly equal to zero, but we are getting fairly close to zero. So Excel solver can help us solve either a single equation, nonlinear equation, or multiple nonlinear equations very easily. Now, the next slide, we will see an example of the ideal gas, the equation of state. Now, in thermodynamics, you know that the ideal gas equation, which is PV, pressure times the molar volume, equal to R times T. Now, this equation can be solved very easily for volume. However, in non-ideal cases, like for example, the van der Waals equation of state, it is a complex equation of state, relatively complex, and you can see here in term of volume it is square. Okay, it is quadratic. Now solving it for volume, in case you know that the pressure and the temperature, it will be you'll get two roots. Okay, so to solve for these two roots, we can use the solver approach. Okay, now if you want to solve it, if you know the volume and you want to solve it for temperature, it's not a problem. You don't need the solver method because it is not higher order in terms of pressure or temperature. However, it is higher order in terms of volume only. So the van der Waals equation of state is given by P, the pressure, plus A is a constant, by V square into V minus B. B is a constant and is given by this equation equal to RT. Now to solve this equation, Microsoft Excel, for the volume at certain conditions, we can use solver, as I said. For example, here we have the ammonia at certain conditions. This pressure, this temperature, and this critical pressure and temperature are available. We want to solve it for the volume. So how to do that? First of all, let us adjust our equation. We want to take the RT to the other side. So the equation will become P plus A by V square multiplied by V minus B minus RT equal to 0, as shown here in this slide. P plus A by V square into V minus B minus RT equal to 0. This will be our objective cell. We can also calculate A and B by using a formula. Let me show it to you in Excel sheet here. So we have the pressure, it's available to us, the temperature, the R, the TC, and the PC, and we can calculate A by the formula, which is 27 by 64. It's shown here. Let me show you. 27 by 64 R times TC square by PC. So if you look here, R, which is this one, 8.314 divided by TC, and so and so. So we calculate A and we calculate B. For the volume, we don't know any value. Let me put, let's say, 90 as the initial guess. And the f of V, which is P plus A by V square into V minus B minus RT equal to 0. Now in solver, our objective cell is the f of V. Okay, and this is the objective cell f of V. I want to make it 0 by changing the volume. Volume is our unknown. I want to solve it for the volume. When I click on solve button, it will give me the solution, and it is 104. It's solved, and the f of V is a very small number. Now again, remember, it is a quadratic equation, so we have two roots. You see, we have, if I plot the f of V against the volume, okay, we'll see they have two roots, and first one is nearly 40 and the second one is nearly 100. So if I change the initial guess to maybe 20 or whatever and click on solve button, we'll get another root which is nearly 43 or another solution. And if I change it to maybe 60, the initial value, and click on solve button, I'm still getting the root near to that, but if I go to maybe around 80 or something, then it will give me the higher root. Yeah, 104. Now from here, okay, by the way, so why are we getting two volumes? Two volumes because maybe at these conditions, the ammonia is in the two phase and the liquid volume is a smaller one, which is around 43, while the gas volume or the vapor volume is around 104. Similarly, we can solve the Peng-Robinson equation of state. I'll give you that problem in the homework. Okay, and we can it's available here. We can solve it. It's a slightly different equation of state, and you can solve it for the molar volume here also. The next slide, we want to apply we want to solve the multiple equations, okay, nonlinear equations. We solved it already, but in this case we want to apply it to uh, a specific chemical engineering problem, the calculation of dew point by using Raoult's law. So the dew point calculation using the Raoult's law, again we have multiple equations. How? Imagine if you have a container of liquid, a mixture of liquid, well, let's say component A and B. So there will be an equilibrium in the vapor and the liquid pressure at certain time, and at certain conditions, like for example pressure and temperature. At certain pressure, for example, there will be a temperature at which the vapor will start to condense, okay, and that is known as a dew point. How can we calculate that? We can calculate that temperature, if you know the pressure, by using the Raoult's law, which says that the liquid pressure times the liquid mole fractions times the total pressure, Ya is the liquid mole fraction of component A times the pressure, is equal to, uh, sorry, Y is the vapor mole fraction, okay. So the vapor mole fractions times the total pressure equal to the liquid mole fraction times the saturation pressure, okay. And similarly for component B. However, if you look at the saturation pressure PSAT, PSAT is given by the Antoine's equation, okay, 10 to the power 6.893 and so divided by the temperature, 219.9 plus temperature. The temperature here is in degrees Celsius. Now, look, it is non-linear in terms of temperature, so you cannot solve it directly, okay. We need to solve it by some numerical method. So to solve it by using numerical method, we need to have other information, like we know in this case the vapor mole fraction Ya and Yb and the total pressure, but we don't know the liquid mole fraction, okay, Xa and Xb and the temperature. So we have three equations, 1, 2, and 3. We have three equations and three unknowns, and using the solver we can solve it easily. How? Let me show it to you. So here we have, so I'll make an Excel sheet here. I define the pressure, which is 150, the liquid mole fraction 0.65, the for component A and for component B. Sorry, the vapor mole fraction. I'm sorry for messing this up. So we have, we know the vapor mole fraction, okay, and we have Xa, Xb, and T. These are the red ones, and they are the unknowns. Okay, let's say we don't know them. I assume it 0.5, and the temperature to be 30, just randomly. Okay. Now we use the equation which is given to us to define the PSAT. PSAT is given 10 to the power 6.893 and so, and PB. I'll define them here. So PSAT is defined here, and remember it depends on the temperature that we assumed, and this also depends on the temperature that we assumed. Now we have three equations. The first one is the total mole balance, which is the mole fraction of A and B must be equal to 1. So that is true. We can write it here that 1 minus Xa minus Xb will be equal to 0. So this is 1. The second one is Ya times P minus A. If I take this to the left side, so it will be minus Xa times PSAT equal to 0. So we have the second one. And similarly we have the third equation. Now we have three equations which we want to be equal to 0 by varying these three values. So we have three equations and three unknowns, and we can solve them easily by going to solver. We can choose, as I told you earlier, we can choose any one of these equations as our objective cell. For example, I choose the first one as objective. I want to make it 0. The other two, I choose them to be F6 and F7. I choose them to be in the constraints and must be equal to 0. And the variable, I have three variables, D8 to D10, D8 which is XA, XB, and so on. So let me just, when I click on solve, yes, solved, and this is our liquid mole fraction 0.29, 0.71, and the temperature is 55.8, and all of the three equations are satisfied. We can solve more than three equations, 4, 5, and whatsoever. Okay, there's another question which you should practice on your own. You can use the solver function and solve the following two equations, where we have two equations, okay, and two unknowns. y minus x square minus 2 equal to 0, and y minus 1 minus 5x plus x square will be equal to 0. However, you need to have two constants. X must be greater than or equal to 2, and y must be greater than or equal to 3. When you put these two constants and solve it, will have a unique answer, and it should satisfy the both the equations. Similarly, you can do the practice problem by using Penn-Robinson equation of state, and under a given condition, you should solve it for the molar volume of the ammonia. Okay, and you will see other problems. I'll upload them to the Blackboard, the practice problems, and some homeworks as well in the coming weeks. Thank you so much for your attention. Please reach out if you have any questions.